Have you guys used Prezi before? No? Where's my present button? Just wait then. If you've never seen Prezi before, or you have, this will be fun. Taylor, could you hit the light? I'm going to pretend that that's going to make it cooler in here. Okay, so we're going to start, like I said, the first part is not out of the book, but it's just background knowledge. So what we're going to be doing the next couple of weeks is figuring out why that is not on the screen the right way. There we go. Okay. So we're going to start with stuff that you guys should already know, but we're going to go for as a review. And so the first section, section A, is called Surds and Radicals. So like I said, you can take your own notes, whatever that looks like for you. Don't take it on the same page as that daily challenge. Because remember, you're going to turn that daily challenge piece of paper in. So don't do it on that same page. And another little strategy that we use is called a, oh, whoops, never mind. Zooming in on the title. I don't know, last year my students never wrote the title down right away, so I like to zoom in so you guys got that. So the first section is Surds and Radicals. On the top of your paper, just draw a little box. So it doesn't have to be the top, somewhere in a prominent space, draw a little box. And we're going to come to the stop box again towards the end. Sometimes it's towards the middle, but for this chapter, it's pretty much towards the end, and we'll come back to it. And here we go. I tend to get very excited, so if you need me to slow down for a second, let me know. I want to make sure you got a chance to get everything down. These are just some of the things that you guys should remember from your previous education in mathematics. A radical is any number which is written with a radical sign. So in this case, I got the square root of 8. And then a word that you might not have heard of before, but you've definitely worked with, is called a surd. A surd is a real irrational radical, such as square root of 2, square root of 3, square root of 5, or square root of 6. So it's one of those irrational numbers. So if I were to evaluate that on a calculator, it's going to approximate the first few decimal places for me, but it would go on and on forever. And it can't be broken down. It's not like the square root of 16, which, what's the square root of 16? Good. You know, I can break that down. And we can also break down something like the square root of 32. So the square root of 32 is irrational, but we can break it down. So a surd is one of those that can't really break down anymore. I sort of already said this, but a square root of 4 is a radical, but it's not a surd. Anyone want to give a shot explaining it? What do we got? Absolutely, you can simplify that more to be 2. And then keep in mind that we're not going to have negatives underneath that radical sign. And that when I multiply two square roots, square root of a times square root of a, it's just a. Besides the word surd, is everything else looking familiar? So some of those properties, just like I mentioned, that it'll never be negative, so that square root of a does have to be greater than 0. And also, a has to be greater than or equal to 0. We'll talk a little bit more when we get to our functions section about like when we have those domains that don't work and stuff like that. But that a, what's underneath that radical symbol, does have to be greater than or equal to 0. Multiplication property, that if we've got the square root of two numbers multiplied, like a times b, then we can break that up to the square root of a times square root of b. And same thing where we have the square root of a quotient, we can break that up into the square root of A divided by the square root of B. And in that case, B cannot be 0, it has to be greater than 0. We know we can't divide by 0, right? So we're going to get to just a few examples here just to make sure that these properties are coming back to you as we start going. It looks like people are still writing, so I'm going to slow down. If I sit here, you can't see from me.
No, I can see.
You can? Okay. Are we all right? Okay, so the first example, write as a single surd. So if I've got the square root of 2 times the square root of 3, it's kind of the converse of the property we had with the multiplication, but I can multiply those two numbers that are under that square root sign and keep it under the square root sign. So what is 2 times 3? Come on, you can say it loud. I know you got this. 6. All right. So can I break 6 down? No, so that's it. Again, I know we're easing into things here with some background stuff. You guys will be all right. All right, let's see what else we got. Ooh, that's really high up. Okay, anyone remember how to handle these? There's a couple of different techniques that you can do to handle this type of problem, but I want to know what you guys remember. What do you got, Nick?
Put it all under one.
Yeah, that's probably one of the 3 different ways. So we could put it all under one radical sign. So 18 divided by 6? And 3 is that single surd. I can't break that down anymore. There are other ways to approach that. So if that was not like your first instinct, that doesn't mean that you were wrong or that you get the wrong answer. You're just kind of taking a different path. This is probably the most direct path. We're going to work on breaking down some stuff in a few here, but you could break down 18, or you could rationalize the denominator, which we'll talk about. All good so far? All right, so I know we didn't have one of the properties of adding. Does anyone remember how to add radicals? What do you got, Mari? Absolutely. If your radicals are the exact same, then you could add the numbers that are outside of it. So since I have square root of 3 and square root of 3, I leave that the square root of 3. It doesn't become square root of 6. And 3 plus 5 is 8. It's kind of like if you remember combining like terms. Like if I had 3x plus 5x, you guys would say 8x, right? So it's that same idea when those radicals are the exact same. And then I'm not sure why I have another one like this that I'm sure you guys can do on your own without me. All right, take 1 minute for that one. Alfred, you got that one?
Yeah, it'll be -3 square root of 2, right?
Beautiful. All right, let's give Alfred 2 claps on 2. 1, 2. See, I gotta get used to it. Okay, so this one might throw you for a loop or might not. I've got 2 square roots of 75 minus 5 square roots of 27. So the deal is 75 and 27 are not the same. So I can't add that. And it's not going to be like -3 square root of something I don't want to subtract in my head. But what I can do is break that down. Sorry, I forgot to align the smart board, so I'm a little crooked. What 25, right? So I can break that down into the square root of 25 times the square root of 3. Excuse me. So this 2 still stays outside. Then we know the square root of 25 is 5. So 2 times 5 times the square root of 3. 2 times 5 is 10. So I've got 10 square roots of 3. Does anyone have one of these type of calculators? I could have guessed this earlier. Yep. Like the white ones? You know that these babies simplify that for you, but you should still be able to know how to do it, just in case you don't have one of them with you. So then, what about 27? What do you got, Noah?
You can simplify that so that it'd be root 9 times root 3, which then would be 3 root 3.
Beautiful. So 9 times 3 is 27, and 9 is that perfect square. Exactly like he said, that's going to be 3 root 3. So then I've got 15 square root of 3. So are we okay with that? I know it's the first one we had with the breaking down, but again, it's background knowledge, so I'm hoping you guys got that. I end up with negative 5 square root of 3. And I tried to do that in my head, this little success criteria. I didn't realize it was like the exact same. So I have to change that. Okay, so we've got one last example for you guys here. Okay, so rationalizing the denominator. So that's something that you guys probably did in Algebra 1 and in Geometry and last year in Trig, where we want to take that square root out of the denominator. Now, here's the catch. I do want you to do this today, not this assignment, but in the future, the IB kind of says, whatever, you can leave that square root down there. So it is important that you can go between both ways, because you might see an answer with the square root in the denominator, but you might have put it out of there and all that. So you need to make sure you can go between the two types. So when we want to rationalize, we have to multiply by what's in the denominator. So whatever square root is in the denominator. So then I've got 9 square roots of 3. And then my shortcut, which we talked about on the properties, square root of 3 times square root of 3 is just 3. And then I can reduce 9 over 3. 9 divided by 3 is 3. So I end up with 3 square roots of 3. So I do want you guys to do that rationalizing today, but like when we get to some of that trig stuff, do you guys remember like the sine and cosine and all that? A lot of times the IB will leave that square root in the denominator, which you might be used to it not being there, so you do need to be able to recognize both types. So we're going to quickly go to that stop box. So this is exactly what I was just talking about, how the IB gets kind of funky with that. Write yourself an example. So write something with a surd in the denominator, and then rationalize it, just so you've got that. Actually, let me think. What do I want? I don't know, this might be a good one. I don't know. Or you can make up your own. So that stop box is supposed to have something that you guys can go back to. So sometimes I'll try to get you guys to write yourself an example. Sometimes it will be just giving yourself some tips or certain questions. So that stop box will change. And your assignment is a worksheet. It's not in the book. For most of the year, you're not going to get this lucky once we get to the normal stuff. But for now, the answers are on the back so that you can check those answers like we kind of talked about yesterday. And Ms. Krantz and I did not put this like specifically in the syllabus just because it might end up being a little bit flexible, but what I want you guys on these assignments is to take 2 days. So today's, what day is today? Wednesday? Alright. So today is Wednesday. You can come back tomorrow if you have any questions, and then the assignment will be due on Friday. Does that make sense? So you got tonight to do it. I mean, I wouldn't put it off, so that you can ask me any questions tomorrow, and then I'll check to make sure it's done on Friday. And so we're gonna kind of keep that pattern up. And have you guys checked out books in any classes yet?
Yeah.
Yeah? So did you use this? Okay. So I know we don't need our books for a while, but I'm gonna start checking them out because I have to like scan it like I'm a librarian and stuff. So I'm gonna call you guys up to grab a book. I'm gonna check it out too, even though if you look on your calendar, we won't need it until we start chapter 1. But I'm just gonna get it so that we got some space.
We just leave it in our lockers.
Yeah. I'll try it. Well, we've got like the background knowledge test, so it'll be like after that. But I'll try to remind you guys too. Are we good with the lights off? Like I imagine that it's less hot. That might not be true, but